So what do we do if we're trying to solve a system and we know that the solution is something like maybe a 29/57 and 1/13? What do we know if that was the intersection point or the solution to a system? That would be an awful difficult solution to discover through the graphing method. That would require a super amount of precision that neither one of us has, especially if we're trying to draw it on paper ourselves. So what do we do? Well, there's two other methods I want to introduce you to help us solve problems that might have a little bit more of a complicated solution. And one method is called substitution. And it kind of sounds exactly what it means. So let's imagine that we have a system. And it's important if we can write the system down accurately so we're solving the right problem correctly. There we have a system. My general notation I use, I'll just put it around blocks. However, you'll see other people describe a system maybe with a different set of a boundary on that. And that's all right. Both ways are fine. What we do then is, as we're trying to solve a system through substitution, is we look at both of these equations and try to determine which equation would I like to solve for a particular variable. That's our first goal. Rewrite one of these equations in terms of a variable by itself. For me, it looks like the second equation may be easier to solve for. So what I'm going to do then is I'm going to work this system out by rewriting the system. The second one, I'm going to solve for x. Put my blocks around it just so I know that everything's still within that system. So I have the same system. Both of these equations, both of these sets show the same equations. I didn't do anything to modify to change the equation. I just modified it into a different form. But it's still the same. So if I were to graph this, I would still graph the same line as I did there. So why did I do this again? Because I want to try this idea called substitution. So what that means then is I'm going to take what I solved, in this case the x, and I'm going to substitute it in to the other equation. So I'm going to make it a 5. I'm going to substitute it in. Notice what I did. I took the other equation where there was this x. I substituted in the other equation's value of x for that spot. I want you to notice what happened as well when I did that. I combined my 2 by 2 system, reduced it into a 1 by 1 system, meaning originally I had 2 equations and 2 unknowns, which means it can be solvable. I reduced that down to a 1 by 1 equation with 1 unknown, which again means it can be solvable. So let's work that out then. If I were to reduce that down, combine terms, add 15 to 9, I get what, 24? So if I were to solve that down, notice that y equals 4. So I found half of my solution. How do we find the other half? Well, we take this value and we bring it up to my 2 by 2 system and solve for the other value. I could plug it into any one of these equations. Those were the first 2 I started with. Maybe it'll be better or easier to do it into one of those second ones that I modified with. As long as it's one of your 2 by 2 original equations, any one of these will be fine. So it looks like this one for me might be the easiest one to do. So I'll take x minus 2. I'll take my value of y, which was a 4. And from there, reduce and solve that down. Get the value 3. So my solution to the system is the solution of 3, 4, or the coordinate point 3 and 4. If I were to graph it, that's where the 2 lines would cross at. Using the substitution method, I found the solution as well. And then if I wanted to check both of these, because I know these points are the correct points, I could check it into the other equation to confirm that I found the right solution and did not make an error or a mistake. All right, what do you guys think about substitution? Kind of cool, isn't it? And just as I was saying, check your solutions. That's what I did. And I noticed I did make a mistake. You guys saw the mistake, didn't you? 2 times 4 is not a negative 6, is it? Yeah, let's just cross that puppy out. So let's try that again. X minus 2 times 4 equals negative 3. X minus 8 equals negative 3. X equals 5. There we go. That's the correct value of 5, or of x. So my solution point then would be 5 and 4. Good thing I checked the solution. I make mistakes too. Good thing in math, we have a process to find out, did we make a mistake or not? All right, sorry about that. Are you guys all right?